Recording in progress.
But we also have other things. We have been, we are now the next generation for some other people who have inspired us in the past. And this is what we strive to do with outreach. And the point again to make in this particular talk is that this generation also lives in very remote places and or in the urban areas with economic challenge background. You can see my team reaching a place, a school where the children have to cross a stream. So this seems like, in the past, like Lal Bahadur Shastri or somebody used to go across a stream or something. It's always as a reality. And in one of our efforts, we actually have to do that. Right? The children do that every day. They cross the stream, they move their shoes and do that. Right? So are we reaching them, and can we reach them with any things which are low cost? Okay. So low cost is again the driving point, and whenever we have some resources at hand, there's always a pull towards various direction. And if you have to do something at a larger scale, okay, we have to therefore involve things which are local. We need to find material which is local, resources which is local, use language which is local. So be very conscious about that. So, few examples, because it's astronomy, I'll start with an example of low-cost telescopes, which have been designed and used at IUCA for a very long time. In fact, Professor N.C. Rana was one of the driving forces of designing a low-cost telescope, which you have to have good optics. You can't compromise on that as astronomer. So, except for the lens and the eyepiece glass, most of the other things can be bought at any hardware store or a stationery shop. So this is our what we call the Galileo scope plus, which improves upon Galileo's rudimentary telescope. And now we also have an attachment again made out of PVC things, which also can help you show the sun's image. It's about 2 inches across, and there's always this problem of outreach with the sun. If you point a telescope to the sun, invariably somebody will try to go and see through the eyepiece. Although you're projecting a huge nice image there, they'll also say, it doesn't get it's gone. We have come up with this idea which
Samir, now 26 years ago when Rana did, it was only wooden box.
That's right.
Not even PV.
Not even that. Yeah, we have changed over the time, of course. That's what I'm saying. The seed was there. And then this is quite easy to make. As I said, the materials can be very local. You just need to take a lens there. You don't need to transport all the whole thing by courier or something. And this is a workshop happening in Kohima, Nagaland. Okay. With very local material bought there itself. Just took the lenses. I'm just showing it as an example. And then there are these things that you are referring to. The stands on the stands can be wooden. This is a design of a reflector. I think IIA also has a similar effort, just showcasing the IIA cover, which has a lot of things which can be brought with locally and made. Okay. There are also supported by other organizations where we could spend about 10 days grinding the glass. This mostly happens in the IUCA laboratory, but we support people if they want to come there, grind the glass, etc. Most of the material we support with. And IUCA's Girovli Observatory and the 2-meter telescope, which also needs to be coated every few months. So then we also help them, the amateur astronomers, by coating their mirrors for free after they've made it. So, and these workshops are possible all across the country. We've done them at various levels. So, some places there are these small refractors that we make. Some places people can buy kits and then put them together again with local material. For some places they can go right from the scratch and make them. And with this, about 300 telescopes are being made every year. It's not a bad number because many of these are made by amateur astronomy groups or teachers who then reach to many other people. So it's not just one telescope going to one person. There are multiple recipients of the telescopes. And so I'll again emphasize that the scaling up is also very necessary. And we also have a lot of other low-cost things that we are doing, including making small spectroscopes. We have a few experiments that schools can do just with a ruler, that meter scale that they have in their school. Just giving examples here. And this is an example of the India International Science Festival, where a world record event was done with around 2,000 students making spectroscopes all at the same time. And very good spectroscopes. They could check them immediately and see spectral lines. Yeah. Keep them in their pocket and go home. We also have a small cycle that we have designed, which has on it about 20 experiments. This guy is a science toys. Science communicator can just replicate this with all the things which are out open source. You can sit on it, drive to some place, park it there. You don't need a van. You can do it with a cycle also. Is what the point that I'm making. Okay. Then these are some other activities which I'll just throw in the open if anybody wants to discuss. I'm happy to do that. So we have educational role play that we do with during teacher trainings. Again, not a novel new idea from us, but it's very effective and doesn't cost anything. Just you're using your own body to explain that. We have, of course, free interactions. You can see JVN still comes every time there's a big public interaction. We sit on stage and ask questions. We have been using local material, as I said. So CDs and straws and small rubber pencils, etc. are used in our activities. You'll see soon. Mobile planetariums are also another thing, another resource which I have been very happy to use very effectively. Usually these are seen inside science centers in a room. So it's called a mobile planetarium, but it's never mobile, it's just there. So we've been happy that you have supported it us to have two mobile planetariums. And we've been able to reach about close to 5-6 lakh people with this kind of setup. And this is very easy to fold up and take to a village and just set it up. This is actually happening in a village in a marriage hall. You can just find a place and set it up and do good outreach. Okay. Then of course we just don't cater to our national audience. There's also international interest in our low cost activities. So with online, we've been very, it's been possible for us to reach out very far. The workshop happening with teachers in Bhutan, not too far off, but they were very happy to do that. And there was no such exposure earlier. And because we were using social media, we were going online with all our workshops, announcing them. They got interested, got to us, and now we are also able to do that. So large scale is again a need for many countries, and we can also cater to that. So with that idea, one of the activities which has started in Ayodhya but has been taken up at a larger scale by various institutes and groups and ASI BOEC is the Zero Shadow Day, where on certain days between the tropics, whatever objects are there, they have the least shadow. And if your body or you are cylindrical in shape, then you will have no shadow. Okay. That's a Zero Shadow Day, which has been done and accepted by many educators across the country. This is a show happening on the Zero Shadow Day of a particular school in a remote place. And of course, this has appealed for all the countries which are within these lines, the tropics. And we basically connected about 100 countries with very underprivileged, very economical backward countries as well. Okay, so that's something we do with my advertising slide. But let's go ahead. I also stressed on large-scale collaboration because this was supported by POEC and therefore it became a big collaborative activity. And again, another example was annular solar eclipse, which was webcasted with POEC involvement, and then many institutes joined there as well. Right. So that was a really collaborative effort, and of course now such things have become more popular. So whenever there's an event, I also stress on large-scale collaboration because this was whenever there's an event, people look forward to it, and now all the institutes are doing and getting much more numbers. At that time, this was a big number. Of course, it still is. Now we are reaching much higher. So to mega projects, which can also have a big role to play in supporting outreach. So as Neeraj said that since Ayodhya hosts the science part of LIGO India, we've been doing a lot of work close to the site at Hingoli. So again, very economically challenged district with the people often going out of the district to various other places to work. Okay. And in a way, of course, it's useful for LIGO India if there are no people around for such activities happening. But it's not just a joke. But the people there still are facing a lot of challenges in education, in various other things also. So we are starting with making friends with the teachers there. And that also helps us build a good image for the project. So these are the things that we have started. And most of these, as you will see, do not have very big costs associated with them. It's been really effective, and over the last 2 years we've got a good rapport with the teachers. And I'll tell you an example where in the beginning there were some people from LIGO who came and looked at the site and with some Indian scientists. And as soon as somebody sees a foreigner there, they say, "Oh, NASA person, right?" So everything in astronomy is done by NASA. So LIGO India is being built by NASA. That was the most popular thing going around, the popular rumor or whatever going around. And then when we went to do outreach, they said, "Where are your NASA people?" Now that is gone because we work with the teachers, because we did a lot of other things. But I'm just saying this is a background thing which happened, which we didn't even say, had to say that, okay, we are not NASA or bad, NASA is bad or something. It just happened organically, and now everybody knows the important Indian scientists who are working for this, what is going to happen. We in fact also have a cartoon book which we made there, especially in Marathi. So that is what funny. So coming to today's attraction, we are here to showcase kit that we have made for the awareness about radio. This is supported by IU and SKO, and some of the institutes who are involved in this particular workshop that we are doing here. And we named it Sokar and Soru Kit for awareness about radio astronomy as a homage to Professor. And so it's basically we try to connect the classrooms with radio astronomy. Because suddenly jumping into a classroom and saying, okay, let me tell you about GMRT or the is weird. So we have taken some steps, basic steps of first explaining the science related to astronomy, then bringing in some concepts of astronomy, and then going to radio astronomy. And this is kind of being neatly packaged. The material is here on the desk. We're taking a workshop here, as you can see, and then it will package into a box. And later, more fundings, we'll probably be able to distribute more number of these boxes. But our main aim was to keep the price of the whole at 3,000 rupees. So I mean, the project was written in that way. It should not be high cost. So my team is here, and we'll demo a few of these. And just keep our advertisement page here. You can welcome Shivani and maybe I'll just enjoy from that or this. Keep this here. I'll just say that this is the prototype, and if you see any mistakes or anything you want to add, you want to discuss with us, if you see any logo is wrong, please don't take this as an official, thing. Let us know. We are still updating and bringing it to the final stage where we then present it to SK officially. We'll also have a manual. So we'll have about 12 demos, which can be 12 things which can be made out of this, and then it can be used for approximately 20 activities. But then that is just the limit, our limitation, imagination. I'm sure people can find other ways to do it. So that these things will be listed in this prototype manual that we have made, and will be given to people along with the box. The box and manual will be the part of it. So time, how much time will be?
12.
Oh, no. Yeah. Okay, so we started this with talking about, divided the whole world over the kit in two themes. So one is how do we see things, and then what do we see in radio astronomy. So this is the how do we see kind of part, which is more relevant to the syllabus also. And in that we have first a model of an eye. So there's a lens that is part of the kit, and there's this model of an eye, cut out of an eye. Here, made out of this one is 3D printed, but we also have a locally makeable thing which is made out of just a plastic ball. Make a hole here, put the lens onto it, okay, and then make a hole here and put a pipe. This is a PVC pipe. It is plumbing thing. You put a butter paper here at the ground and put it here. Okay. This part goes inside. So this is just basically a box camera in a way, but shaped like an eye so that they can relate more to it. And I can do it as focus it, and then I'll give it to you to look at it. You can focus it for your own eye. So let's do it. This can just be passed around. It's low cost energy. The kids play with these balls, they go bad. You can just cut it and make an eye model out of it. We in the kit we are giving a more fancier thing, which is been hand printed by Shivani to show the optic nerves and things like that. And so it's not just useful for a physics teacher. Biology teachers can borrow from the kit and talk about their part of the eye and vision. That's there. And then we also have then after we talk about eye and how things are seen, we go into what is the relation between that light has energy. That is one concept that we want to focus on. And so we have a magnifying lens that we give. One of the activities, of course, is to burn a paper. That's very fun. So it has to be done but the magnifying glass being given is many a times not present in school. Okay, so that's another thing. So magnifying glass can not just be used to show that light has so much energy it can burn a paper, but it can be used for anything else, even biology. Okay? Yeah. Could be a useful thing, even just to see. And because if you point it at the sun, this LED lights up. It doesn't work so much with this light. And then later it can always be repurposed for other things. It does stop. We allow the teacher to, with something real, talk about photoelectric. Yeah, please.
Sun is closing.
Yeah, you have to. And see, I can easily give it to him, tension free. It's not like, oh, there's this kit which the school has bought for 20,000 rupees and most of it will be locked in the cupboard. Just give it to them. Yeah, it's so bright, you can see the lights. Okay, you just turn it off. Yeah. Great. So that's a relation of light and energy, and then we come to some demos about wavelengths and frequencies, and then try to relate it to them. This is a very general kit, but we are slowly coming to that one.
In the sense that you
We are coming to that. So we are only at the third topic. We have about 12 topics. Slowly we go from vision to light, properties of light. Then we come to astronomy, and then we come to radio. So we show you the radio experiment. And as I said, that this is again, we are designing it. So your inputs are very welcome in adding more astronomy part.
Whatever they know the eye model, they know color, they know light. 9th standard kids must be knowing electromagnetic spectrum. So we can take them from there to radio waves. So that's the
So again, something we can make themselves with a sellotape and straws, or you can have pieces of coconut sticks or bamboo sticks, and this can be this is more of wavelength to frequency relation. So you can see more waves if there are more wavelengths, and you can reduce it to frequency less, but the wavelength is more. Something we can show. You can also use it to show the transfer of energy to medium. Okay, so light doesn't need medium, but it's there. A wave can carry energy. Can easily put
And update it for the Doppler shift also.
Oh, let's discuss that one. Then we give a rope again. They can move the rope up and down and make a wave from it. It's also these days. Talking about low cost, teachers and many students also do have mobile phones. So we will include that easily available resource. And so We also have something which can be done with where you create your own waves. Not just with this, but like there's a dabba like this, you can just fill it with water and try making your own waves with some things like this. Because again, low cost is this. It's like drumsticks. You hit the water with that drumstick, you try adjusting your own frequencies. We're not using an electronic frequency generator, but try to do that and figure out what frequency you are doing. This will impress upon them that a wave can carry information about the source. That's what we do usually. We know about the frequency of the source if we detect the light at a far off distance. So just introducing this concept, which they can of course learn about later. Then we come to the spectrum. So now we've talked about waves, but then we talk about various kinds of waves and how they can be together also, which we don't realize. But the light that we see is a lot of different kinds of waves that we receive together in our eye and then we process and see with it. But we can spread them out with a spectroscope. And this one is a cardboard based spectroscope. There are many designs of this, but as I said, we are just putting them all together in one place. So this uses a CD or a DVD for the diffraction rating. And I really like the result from this, where you can easily see the spectrum. This one is a continuous.
Afterwards,
Yeah.
come over
And have a look at this. And so this allows them to see a spectrum, a real spectrum. So we always give an example of the rainbow. But this is a spectrum they can see, and this also has frequencies of colors rather of various types noted and their parent elements from light sources that we most often encounter. Okay, their wavelengths are here. Then they can think, okay, so this color is related to this wavelength. It's easier to remember than just looking at a graph during a cycle. They can take this home and they can think about, okay, so I can see that orange and reddish are longer wavelengths. So the effect of the workshop stays for a longer time. These are the things we are understanding or keeping in mind when we're doing. There's also another resource that we are giving, which is
This was used for this world record, Guinness Book record.
a slightly different design, because here we are using a whole CD. We have a smaller pocket version also, which allows you to use only 1/8 of the CD. So that was, I can share that with you. And there's another thing that we found during our material research is an acrylic mirror. These are mirrors which are flexible. See this?
plain mirror, we can make it a concave mirror. Actually, see that with the lights, converse with diamonds.
With proper research, even low-cost resources could be found, and this was a really good find for us. And this is used to again, in that same water container, we can use it to create a rainbow on a wall. Comes out really lovely.
So dark room and it's always without take water. So sunlight.
As long as we keep them interested with these things, whatever other theory and advanced things we throw at them, they are more receptive to it. And we keep it in their mind later. If it doesn't form an answer but a question in their mind, they still keep it and explore it later. So that's our aim to do that. So then we have talked about spectra. We've seen a spectra of the visible light. How about other waves which may have wavelengths longer or shorter? This ask a question. So we are going to now the longer wavelength domain, which is the radio domain. And in that, again, we are using a short demo. Easy dosing actually. With a mobile phone and as you would call it, a Faraday cage. That is rat cage. We have tried it with a bird cage also. This also works. You can also make it with any kind of aluminum foil. But there's another thing that we want to impress, that aluminum foil will block all light. So it's very obvious that it can block other light. So this does not block light. This is more transparent, translucent. Still, we are saying that wavelengths which are higher than the light that we see will be blocked by this. How does it happen? We use a mobile phone. Many of them have FM radio inbuilt. And they work only when you plug in on this, which also works as an antenna. So wonderful idea that we came up with. Here. Make it louder. Sounds not our favorite.
Then you are clearly.
The reception here is anyway. It's gone now. You only hear the noise coming. Reception here. You might try another tab. This is better.
Going to back, we can validate it.
Yes. Device now and we can take it out. So, so of course, we will be doing this workshop not in 10 minutes, but across the day. Teachers will be introduced to all these things. And we will discuss all these things in detail. In fact, what we are doing now today, and one has been done before, see a picture of, is a workshop with teachers to trial all these things and take feedback. So what we realized there was, from our side, we know FM radio, put in it, it will stop. Now, people, when we told people to start a radio on their phone, they went to YouTube and started an internet radio. This is not radio, right? It's coming by internet, right? This is actually catching radio waves from the station with the antenna and turning it into sound. So they're like, oh, हमारा radio तो चल रहा है. I mean, we did Hindi some this. So they're like, it's working here. How come yours is not working? Then we have to tell the difference. So that discussion also, works. That what is the difference between, in fact, even mobile phones. So then they said, can we try calling somebody on the phone and putting it here? Will that voice stop? Then we said, you first do a small calculation of finding a wavelength of that. Because you know the frequency, can you find the wavelength? Okay. Those kinds of things are unintended or rather intended, but very not obvious things that come out of such demo. So what we are showing you are only demos of certain things, few things. And we'll also, this is something again school usually has, but we are giving is a class to measure thing. And what we are trying to show here, we will show here is we'll fill it up with water and then maybe put a drop of Dettol or something which makes it cloudy. We have a torch here.
Mostly we need a dark room kind of thing for these last few. I'll just
So you put a torch under it and you can see the scattering away of the higher wavelength, higher frequency light. And at the top, you can see, maybe you can see here there is a bottle which the light is more here and it's reddish at the top, right? So we are talking about the scattering. The light can also be scattered off and it's a wavelength dependence. That we impress and then we go into details of that. Then the same thing can be used by them for measurements. They can also use a simple funnel to make a rain gauge out of it because this already has markings. So they can just the geography teachers can borrow this and do something else with it. Okay. This also use of the funnel also takes us to the idea of collecting light. So collecting rain is somewhat like collecting light with a bigger telescope aperture. Right? So bigger the funnel, the more light will collect. All these things also can be brought into the discussion. Is it possible to this way? So this will take us to why we need bigger collectors in astronomy and how we So then there's this is a little more advanced, but again uses very cheap lasers which are available in your stationery. Case powder, this technique here, which can be made concave. I'm still not habituated to that. But you can see the, and then with the convex shape, it kind of diverges out to the top. And to the and of course, we are also giving these the first one. We want to do these are not part of the kit, and this is our stage show, road show kind of things which you just if you want to get interest. That'll do. This you need to be very careful with, and we are not suggesting that reflection. You can basically see the change in direction, and if it was a plane mirror, it would be going directly back to her. Yeah. I'm trying not to reflect it back to you because we do that with the holder, right? So
But these are also very cheap cost of mirrors. Very easy to get. Yes, yes.
smooth can be used. Yeah. That's it. Very correct, very good. So then, when we do this, I mean, because we have to give a kit, so we are giving this, but then there will be an alternate resources discussion also. The workshop, let's stop it here,
Yeah.
but the workshop continues, and in that then we discuss that what all things here that you have seen can be made with local material, not just depending on the scale. So that discussion also happened. Yes, it's a spoon and nice big spoon is a very good example of reflectors. So, thank you. This was what we wanted to present, and now. Yeah, so that's the how we see it part, and then we come to the what we see it part, where it will be more, more presentation based, and there will be information given to them about radio astronomy, the objects that are seen in radio astronomy. Oh, that, why? Oh, you want why radio? Yes, yeah. That's it. So there is actually a lack of those resources as well, and we, of course, as I said, we have the inherent idea is that it should be science awareness, astronomy awareness, and with that we can follow. So usually there's always issue that I've heard many people say that, okay, where do I start? This is the starting thing that you can do. And then we can always follow with events like sky watching, making a small telescope, which of course we cannot include in this kit right away, that part. But that can be a follow-up. Then there are very simple things which can be done at an advanced level with radio, also radio astronomy also. Small telescopes, cheap radio telescopes can be there. There are these small dipoles which can be used for some experiment. That's a follow-up that we will do with SK India later. This is the prototype beginning school level kind of thing that we have found.
So let's go thank before we start question for something you barely see because of talk and a demonstration. I think it'd be nice for us to have more such events here.
Yeah, it's fun.
Okay. So in the meantime, I request people on Zoom and YouTube to write in their questions. Then we'll read them all for the.
So Samir, you mentioned about getting this information about source by observing the waves. So you had two types of sticks. So does that make any difference? Like, is it purposefully given in two different colors or so?
Size, no, that is just two different materials really.
Okay. So because I was wondering, like, if you have to say two different types of stakes with different mass and the top, with the same type, you can generate different waves.
With different masses, you say?
Yeah.
Okay.
So that's how you wanted to interpret it. That's what I was thinking.
That's not my interpretation, but if there is something else, this is a discussion, not like final demo. So we can talk about it if you think there's a change which will happen.
And Samir, you can include one very easy thing here. That is the in the kit. That is the polarizer. So in Presidency University, I demonstrated at that time I didn't have anything. I had the polarizer sunglass.
Okay.
So I just slapped my mobile phone torch and then rotated the thing and
Right.
the intensity changes and it really
It's very drastic.
immediately clapped.
Okay.
Then later on, I bought two polarizer stick from Amazon, 200 rupees.
Right.
So then one stick, if you pass the light and rotate it will change the intensity.
Hmm.
If you combine two sheets, then if you rotate it, then the wavelength will cut and you will get red, green, yellow, all those lights there.
Okay.
And this is a fantastic demonstration, the polarization. Because the sky you can explain. You can
Right.
explain why the cricketer uses those polarizer sunglasses.
Right. Okay.
And it's very cheaper thing, these sticks.
Sure. So that we do have in our optics demo, which is more of a roadshow, as I said, with bigger layers and things like that. Here in this, we have not included, but it's only because we have to also gradually go into these things at a more advanced level. So we are still focusing on the focusing part,
No,
the collection part, the
scattering, no,
magnification and resolution. These three are main things we are coming. Then comes the polarization. So yeah, I mean, I will.
No, when you showed the scattering,
Right.
so you can realize that thing, that this is.
That scattered light is polarized. Yeah, that can be, that's make a note of. I think they're also available in large sheets which you can cut up and.
And it's very cheaper in Amazon, you can buy it there.
Good.
The bulb, as you can see, we have removed all the films from the bulb. And just water and. And you can see that the.
We can show from here the reflection.
Good.
And if we keep that critical angles, then we can show total internal difference.
Wow.
So which is mostly used in our optical fiber cable. So this is from water to air. Again. From air to water. So for this, we just need one light bulb and water and.
Or it could be a flask like. Chemistry.
Can you show total internal reflection on the other
From the
side,
air,
also,
from the air.
from water side, and then from air side?
No, that is not
Yes, I wanted to check it. Wanted to verify.
That's a big question in your interview.
Yeah, so just the scattering experiment that you did, I think now you can also use the white LEDs, which has 3 colors, just to show that red which is still light off.
We'll fill it up with water. Scattering.
Yeah.
There is.
White LED, not.
Right.
Yeah, we have.
Oh, you already have it.
Yeah.
That's fine,
Let's look at it. I'm also.
because I thought you're.
Even that you all have guys to.
Yes.
Yeah, you can just beat us. Yeah.
And you can see them good. Yeah, the one maybe.
So maybe by adjusting the concentration of
Yeah.
you can dramatize it more. Yeah.
So that standard stuff will be also part of the manual where we say, okay, you put 5 ml of this into this many ml of water and all that. Yeah.
This is a rechargeable. You can recharge.
So, yeah, so the torch will be part of the kit again. To enable them to use it for anything. Okay.
So we have a plain mirror, and then raised.
Yes, majority, yeah.
First we used to do the actual duster, and then we got. And then we thought this powder. Yes,
In AC, it doesn't work. So the-
Agarbatti also, some people have problems with the time, so.
But how did you mention that angle? I didn't understand that. This angle changes or it is a,
Two mirrors, they place
oh, you have different angles. Yeah.
mirrors. You can do it with pencil also. The teachers can just show it to the kids and then ask which lens.
This is a general optics demo, not part of the kit. It's showing that it can still do it effectively in case any of you are going and doing a roadshow outside, you want to do a demo in school. It's possible to collect all these things. We can share a list with you. You can start your own show.
Then after you can show this. This is mostly used in a decoration part.
Yeah. Part of the roadside.
Flower bottom.
So we always use this for to tell about the property, those property of better, like on this type of mistake like. But when I use this again. So
Can I bend it? Am I bending it? It's the question which you put. You've seen this at your home or somebody's home. But just to relate it and put it out in a outreach event is the important.
There is like a nice story like which talks about how Indian scientists has
Yes.
invented this kind of
That's right.
phenomenon.
That we can
You can
bring
bring
it
it
back. Sorry, we can just keep going. Please stop.
Yeah, I think, you also need to. So for the last magic show, they will cut Samir in the half and put him back again. After that, they can, so thanks a lot for this, for a very different kind of talk we had at the auditorium. I think everybody here was fascinated. And I think everybody here has got many more ideas as to what we can do ourselves here following this. So are there any questions on YouTube or Zoom? You can just type them in or raise your hand on Zoom. In the meanwhile, we can take more questions.
What I have expected is that when people ask me questions in the general gathering, friends gathering, how things are, etc. Whatever we see around in that room itself, I try to put together and then.
Right.
But we can't demonstrate life in this
Mm.
thing. There kind of things we can do with that. I think the impact is that things are around you, just need to figure out how to put together.
Yeah. So all this you can source it, in a half a day or something.
Yes.
Maybe we should start the house itself.
Yeah.
So you are going to distribute or sell these kits?
These will be, with whatever funding we have, some of them will be distributed to teachers close to the observatories which are involved in SK. And later we'll go for funding to distribute more of it. But then the thing is that if it's cost 30,000 rupees, then we could only give a few with 1 lakh funding. Now it's 3,000, so it's almost many more. And
We thought that the schools can buy it, right?
yeah, how can buy it? Right now, that distribution plan will be discussed with SK and how we want to do it.
Yeah, so like the library buys, no, our Springer books and like, subscription. So they can buy, the library can buy or the science department can buy.
Yes.
And this is not only for schools, sir, college people can also.
Yeah, and there's a next version coming, which will have additional stuff, maybe it will cost 5,000 or 10,000.
You need
To
to
have
have, yeah,
college
you need
level.
outreach for this one. So you have to advertise this thing and then see that.
Publicity.
Yeah, publicly you can sell it, yeah.
We'll see.
Yeah.
Well, we are working with the government on this. It's just that. But, inputs are always welcome, not just finish with our story, but it's free to talk to us about this. And any other low cost outreach, if you are feeling inspired, we can do something together.
Oh, yeah, you had a question? No, oh, sorry, then Ravi, then.
Yeah, so submit the kit and also so when you go and demonstrate it. And you made a very nice comment that not just the answer, but you want to solicit the questions. So have you also thought about the guided kind of learning and questioning, the material that will go with the kit? I mean, that I think that would be much more useful for the people who go and train students. So you tell in such a way that the questions are elicited, students.
We have some trainings which we do with educators, informal and formal, where we share with them that how this same thing, same concept can be explained in a different manner, which elicits questions. That kind of training also we have. And in this particular one also, we have done only limited workshops, but that discussion part includes getting questions. So in fact, when we are showing them, we are also getting them to think of something. Then they understand that it's useful to think. And not all questions will get answered. And then we, specifically show it to them that, see, you thought, now can you speak in a way that children will start thinking based on what you say. And this is of course it's not just given to them, but there's also a plan of following up with some teachers for 6 months. That's why this is a limited thing right now, limited number thing. We'll be following up with them and we have their contacts. And they are not expected to do this as a road show in their club. But if they have something like a science club, which is an extracurricular activity happens every Saturday or something like that, they are sometimes looking for material, what to do in that activity. This will be the fodder for them. They can use it over an extended period of time. If they come across a question on one Saturday, they can call us back, saying, can we together discuss an answer which I can give him on the next Saturday. So this is planned as a long-term activity with some people.
Yeah, because what I see, because it has enough material for people.
Yeah.
So it's like a tendency is that we start explaining things, right? Which may not be the most effective way of communicating, because the idea is to get people think and answer. That's one side. Another side is how the magic happens. The magician never tells you the trade of the tricks. He'll only show you, right? And there are questions in people's mind, but you never get the answer how somebody's head is cut or how someone is like. So I think so. It's like bringing it to somewhere in middle where people can start thinking about.
So I'll just express it a little bit more that this is something we designed. What material can be given? Now after that, we need support from the whole astronomy community in actually going to the teachers. If you can spare a day from the year and talk to, let's say, 10 teachers, and then take a few calls across the whole year from them, then I can give so many of these skills. So I don't have to go and do 25 events at places. Each of you can have one such kit and adopt a school or something. And see, just if there are 30 people here, you have outreach for 30 schools or so many students who will pass on, and this can be used over the years. So it's not just the SK responsibility that they create the kit, but it's all our responsibility also. We use it. So I also appeal you that when this comes to a final stage, please adopt it. Buy one. You also should buy one maybe. Okay, and you should give to your school where you study, nothing else.
Yeah.
Yeah, in terms of radio astronomy, you want to introduce, bring in that aspect also. And if you're thinking of advanced kit, there are FM transmitters.
Right.
So since you have FM receiver already as a part of your experiment, which is like a mobile board, you can also include a transmitter, and then somebody can talk, like the students can go a little distance and then
Right.
start talking in that small kit, which costs few hundred rupees only. And then they can receive, and then you can explain how the signal was modulated and so on and so forth. So for advanced students.
Yes.
Another thing is related to astronomy, there is something called forward radio scattering techniques. So in which what people do is they coordinate within themselves and then establish their radio stations, like which is FM radio, which is tuned to a nearby city.
Okay.
So for example, from Bangalore, you tune it to Mysore, so that you will not listen anything, because typically FM stations are having different zones basically. So frequencies are allotted to nearby cities. So you tune to a wrong city or other nearby city. Whenever there is a meteor shower or so, that time ionosphere gets ionized, right? And then it acts as a reflector for that FM station. And then you will be able to receive a small bit of audio, which is meaningful from that. Yeah. And then using that, and it is also coordinated by IMO, so International Meteorological Organization. So that becomes an astronomy experiment with a small radio telescope at that college or so. So for advanced students, it can be you can think of including it. It doesn't cost anything. Everyone has FM in their mobile. They just have to tune to a wrong frequency and keep recording it.
Okay.
So that also can be thought. So though for those who are interested, like even if you manage to get 10 or 15 stations like that across say India or so, that is also good.
Okay, so it was the opposite of low cost, that's what I mentioned. Also low cost is low cost telescope, the billion dollars. So what they did actually was they looked at meteor trail momentarily, they managed to catch the reflection in the Netherlands, and then they could decode that fraction of a second thing and recreate the frame of a Swedish TV channel. So that was really good.
But it costs 100 rupees.
Yeah, it's very, very
Right, it is, yeah.
A dedicated FM station, which is like a digitally.
We actually, I'm just sharing the hurdles. So we came to 2,800 rupees with some of the material, and then after that, only 200 is remaining to print the manual. So, like we organize on our own foot, 3,000, but it's okay.
No, in case
But
it
this is
advanced.
the version of this kit that we are planning, and I'm going to back to you.
Yeah.
Some very nice initiative. So I was just curious whether have you considered including some interference experiments, because SPA would be like real interference, right? So you have something
So you optical interference.
something to demonstrate that.
We have a tabletop interferometer again at a higher cost, which would not include in this. So we'll see how we can make it. LIGO, it's an interferometer. We have some low cost, but not so low cost to be included in this kit. We will we'll try to get it in the next one. But yes, that's good. In fact, I'd be very interested in talking to any of you about the more advanced stuff. How can we simplify it? Like there's even resolution, for example, astronomical definition of resolution is something we could bring it into this. When we define a telescope, we say something which collects more light, makes it brighter, magnifies, and resolves better. Right? So resolving is not just making it brighter; it is a altogether different thing to do. And how do we bring it into the classroom? That's something. That's why I have some 2 blank pages in the manual, because it's thinking about how to bring that concept.
So straight away just put a diaphragm which could just reduce the aperture, and that wouldn't be very difficult to demonstrate.
Okay, but for that I need a telescope.
No, lens would act a telescope.
Lens.
You just limit its aperture. You're putting a diaphragm which shortens or expands.
Okay.
Yeah.
So full aperture will give you best resolution. When you cut it down, you need to figure out what is going to be your object, so that
Exactly.
It can be 2 LEDs also.
2 LEDs at certain distances.
two LEDs on one side, the lens, and then you start reducing this button, as you say, it will merge, and you increase the aperture, it will come separate.
Something mixed lab. We already have those, so we try out at night. Right, thank you. So these are the things, that's why I'm saying that, I mean, this is not a presentation, it's a discussion we want to have, get it further, want more concepts to come in, which can be easily done with the stuff that is needed.
I just want to ask, are there any questions from YouTube or Zoom? Then we will take the questions. If not, so what I would suggest, because you have to go to the Olympic now. And I think he's eaten IA before, he refused to eat the canteen IA. What we're going to do, they're going to go to Private here for lunch. So I suggest that, no, you just come with us, those who want to come to the conversation, just come with us to Private and then have all paragraphs for lunch. Would that be all right? Except for one or two quick questions, if you hate all paragraphs and you have very quick questions, else let's go to that. Anything quick? You don't want to come, you're not going to share that. If not, then let's thank them again on the complete 1 minute. And like I said, you're very good. Just go to the video now and we can have our stand. And they'll go to the